Objects will often have speeds that are constantly changing. So what we mean here is an individual speed changing during a single journey, rather than different individuals moving at different speeds. In the example shown here, the car is not travelling at a constant speed. The speed increases from 0, but then decreases back to 0. But why might a car travel at varying speeds? Well, there are various reasons why a car won't travel at a constant speed during a journey. Traffic will of course cause the car's speed to vary, as it may have to slow down for other cars or speed up to take advantage of space. Speed limits mean cars usually don't travel at a constant speed, as drivers have to abide by rules and adjust their speed accordingly. Changing terrain and hills also make it difficult to keep speed constant, as a driver doesn't control the speed directly, but instead the driving force, which is hard to balance for constantly changing friction and gravitational forces down a hill, for example. So what else struggles to move at a constant speed? And does their speed vary for the same reasons? Different objects in motion can have different reasons for their speed not being constant. So we might have a varying speed while we run, for example. We slow down as we get tired, as the terrain changes, or if we encounter a hill. We may also be running with or against the wind. Naturally, it's very difficult to keep a fixed speed when running. Another example is the speed of wind, which will vary as it's caused by pressure differences in the air, and these differences aren't constant. The speed of a sound wave can also vary as air becomes more or less dense, or if the sound travels through other materials. For your exams, you need to be able to recall these examples of objects which don't travel at constant speeds, but you don't need to recall these particular reasons why their speeds vary. So how can we measure and calculate these speeds if they're constantly changing? We can describe how quickly an object completes a journey using the average speed of the object during the journey. And by average speed, we mean the mean speed of the journey. So the average speed is equal to the total distance travelled divided by the total time taken. Now this is different to the constant speed case, as we aren't considering individual moments of constant speed, we're considering the entire journey. In symbol form, v is the average speed, s is the total distance travelled, and t is the total time taken. So v equals s divided by t. The total time taken is measured in seconds, the total distance travelled is measured in metres, and then the average speed has units of metres per second as we're dividing the distance by time. You need to know when and how to use this formula in your exams, as well as the difference between calculating the average and the instantaneous speeds. Let's have a look at an example. The world record for completing a 42-kilometre marathon is 2 hours. Calculate the average speed of the marathon runner when this world record was set to 2 significant figures. So for step 1, let's write down the key information and check the units. The distance is equal to 42 kilometres. Now our equation uses metres, so we're going to convert the 42 kilometres into metres, which is 42,000 metres. The time is equal to 2 hours, and our equation uses seconds, so we can convert from hours by doing 2 hours multiplied by 60 multiplied by 60, or 60 squared, which is equal to 7,200 seconds. And we want to calculate the average speed. For step 2, let's substitute the values to calculate the average speed. So the average speed is equal to 42,000 metres divided by 7,200 seconds, which is equal to 5.833 metres per second. Then for the final step, let's round the average speed to 2 significant figures. The first significant figure is 5 and the second is 8. The next value is 3, so we don't need to round. So the final answer is 5.8 meters per second to 2 significant figures.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!